Okay, in this section, we'll be sharing some tips for solving dynamics question. I classify the entire chapter into three main types of questions that could possibly come out. And the first one is when the motion is given. So when a motion is given, okay, step number one, what we should be doing is we should be we should identify if there is a resultant force based on the acceleration. So if the question says that the object has a constant speed or is stationary, we would indicate that we should know that the resultant force is zero. And if the object is accelerating, then there will be a resultant force in the direction of the acceleration. And if the object is decelerating, then there will be a resultant force in the opposite direction. Okay, after we identify whether there is a resultant force or not, we need to calculate the resultant force, except for the case where the object is stationary or moving at a constant speed, then the resultant force is zero. We do not need to calculate the resultant force. Otherwise, whether there is an acceleration or deceleration, we need to calculate the resultant force using the formula F equals to ma, given the acceleration. Okay, after we calculate the resultant force, usually the question will not ask for just state the resultant force. They will ask for one of the forces, which is not the resultant force. So we go into step number 3, where we calculate the individual force, depending on whether the question wants is the forward force or the backwards force, using the equation resultant force equals to forward force minus backwards force. Take note that the forward force is the direction of the motion of the object. So if the object is moving up, then the forward force will be up. If the object is moving to the left, then the forward force will be the left. Okay, so let's take a look at an example of how we use this. So a man of weight 720 newtons tried to weigh himself in a lift using a weighing machine. His mass is 72 kg. What is the reading of the weighing machine? So it's already drawn for you over here. So the reading is the upwards force or the contact force between the man and the weighing scale, and the downwards force is the weight of the man, which is 720 newtons. So in this case, the motion is given to you. Okay, so the first part is when the lift is stationary. So when the motion is given to you, step number 1, you are supposed to identify whether there is a resultant force. So in this case, since the lift is stationary, the resultant force acting on the man is 0. Okay, next part, so we don't need to calculate step number 2, which is calculation of resultant force. We go directly into step number 3. So in step number 3, okay, we need to find the individual force. In this case, they do not want to find the resultant force, but they want to find the reading, which is actually the upwards force. So I go into step number 3. Resultant force equals to forward force minus backwards force. In this case, I put so I submit my numbers. Resultant force is 0 newtons equals to, I take it as my forward force is my reading. In this case, the lead doesn't move, so it doesn't matter whether your forward force is downwards or upwards, but I'll just take it as upwards. So the reading minus the backwards force, which is weight, is 0. So reading will be actually equals to weight. The forces are balanced in order to have 0 resultant force. So the reading will actually be 720 newtons. Okay, then we move on into part B, when the lift accelerates upwards at 3 meters per second square. So now, again, the step number 1, we need to identify whether there is an resultant force based on the acceleration. So now there is an acceleration, and the acceleration is upwards. So step number 1, we can identify that since there is an acceleration upwards, there will be a resultant force upwards. Step number 2, we need to calculate how much is this resultant force. So I'm going to use the formula F equals to ma. So I'm using mass, which is 72, times the acceleration upwards, which is 3. So I have a resultant force of 216 Newton upwards. But I do not want to find the resultant force. I want to find the individual force, which is the reading force, the contact force. So again, I apply step number 3, resultant force equals to forward force minus backwards force. And in this case, because the lift is moving up, the motion is up, so the forward force is upwards. So reading is the forward force minus 720 newtons, the downwards force. Okay, I get my resultant force, which is 216 newtons. And then I'm supposed to find the reading. So the reading will be 936 newtons. Okay, then we go on to part C. Now the leaf accelerates downwards at 4 meters per second square. Again, there is an acceleration, there will be a resultant force. And now, because the leaf is moving down, the resultant force is also downwards because the acceleration is downwards. Okay, so step number 2, since there's a resultant force, we need to calculate how much is the resultant force. So step number 2, we use F equals to ma to calculate the resultant force. I'll use mass times acceleration. 2 times 4, I get 288 Newton. This is the resultant force. This is not the reading. So in order to get the reading, which is one of the individual force, I go into step number 3, whereby I have resultant force equals to forward force minus backwards force. In this case, because the leaf is moving downwards, or the acceleration is downwards, so the motion is downwards, so my forward direction becomes downwards. Okay, so my forward direction becomes 720 minus my upwards direction, which is reading. I get my resultant force, which is 288. And then I do my manipulation. I get my reading is now 432 Newtons. Okay, so this is the first scenario where motion is given. We determine whether there's a resultant force. We calculate the resultant force using F equals to ma, and then we find the individual force, be it the forward force or the backwards force. Using the resultant force equals to forward minus backwards force. Okay, that is the first scenario. Okay, then we move on to the second scenario whereby not the motion is given, but the forces is given. Okay, it might be the resultant force that is given, or it might be the individual force that is given. So the step number 1 is some forces is given in the question. The first stage that you need to do is you need to identify all the other forces acting on the object. So it will be good to draw a free body diagram that shows all the forces acting on the object. Okay, after you have identified all the forces acting on the object, you can determine the resultant force based on the forces given. Okay, they might give you an upwards force, they might give you a downwards force, they might give you a frictional force, a driving force. So based on all those, you can determine, and your free body diagram that shows the direction of all the forces, you can determine the resultant force. Okay, and after I've determined the resultant force, okay, so the resultant force is determined using forward force minus backwards force. Okay, after I've determined the resultant force, I can use the formula F equals to ma to determine my acceleration. Usually, if force is given, they will ask you to describe the motion. If motion is given, they will ask you to find the force. Okay, so now, since force is given, they will ask you to describe the motion or find the motion. So most probably, with a resultant force, there will be an acceleration. So use the formula, acceleration is force over mass, okay, to determine the acceleration. Okay, so let's take a look at an example. A balloon experiences an upwards force of 95 newtons. The total weight of the balloon and its content is 61 newtons. Calculate the initial vertical acceleration. So in this case, motion is not given. Okay, a force is given. So the first step, I need to identify all the forces acting on this balloon. My object is my balloon. So I draw a free body diagram. So my free body diagram will look like this. I have a balloon with an upwards force of 95 newtons and a downwards force of 61 newtons because of it's the weight. Okay, next, so I have a free body diagram of all the forces. So that's step 1. Step number 2, I'm supposed to find the resultant force of all this force. So my resultant force will be the forward force minus the backwards force. And because my balloon is moving upwards, okay, it's flying up, so my forward force will be 95 newtons, the upwards force. So 95 minus 61, my backwards force, I get 34 newtons. So there is a resultant force acting on this balloon. And whenever there is a resultant force, then step number 3, I'll go into the motion, the acceleration. So with a resultant force, there will be an acceleration. I just use the formula F equals to ma, and then A equals to F over m. I get 34 divided by the mass. The mass of this balloon and its content is actually 6.1 kg. I get it by using 61 divided by 10. So I get 5.57 meters per second square. So this balloon is actually moving upwards with a acceleration of 5.57 meters per second square. Okay, let's move on into the third type of scenario. The third type of scenario is in words. Okay, they will usually ask you to explain the motion of some objects in terms of the forces acting on it. So whenever we need to explain motion in terms of the forces acting on it, we need to state three different things. Okay, so the first one, we need to identify and compare all the different forces acting on the object. Okay, because they want you to explain in terms of forces. So the first step, you need to tell me all the different forces. So for example, the air resistance increases, or the driving force is greater than the resistive force, or the weight equals to air resistance. All these are forces. Air resistance, driving force, resistive force, weight, air resistance. All are forces. So these are the different types of forces acting on the body at a particular time. So you have to state that. Then after that, I mentioned about all these individual forces acting on the object. The step number 2, I need to state, so as a result of all these different forces, do I have a resultant force or not? And if I have a resultant force, I need to state the direction. So for example, I need to state, oh, so there will be a forward resultant force, or the forward resultant force will decrease, or there is no resultant force. And then after I state the resultant force, I need to link it to the motion because I want to explain the motion in terms of the forces. So I talk about individual force, I talk about the resultant force. Now I need to link back to the motion. And I know that there is a formula that links back, that links the force to the motion, which is F equals to ma. So I will state the acceleration of the object because F equals to ma. So for example, if the force decreases, the acceleration decreases. If the resultant force is upwards, then the acceleration is upwards. If the resultant force is negative, the acceleration will be negative. Okay, so I talk about the acceleration and then I link it to whatever motion I want in terms of speed. So for example, the acceleration decrease means it's slowing down, or the acceleration is 0 if there's no resultant force, 0 resultant force, 0 acceleration, so it's moving with a constant speed. Okay, so let's take a look at this example again of the balloon. I have a second part. It says that as the balloon rises, it experiences air resistance. Air resistance increases to 34 newtons. So the balloon is moving up. Okay, so the first thing you need to know that air resistance will be opposing the motion of the balloon. So the air resistance will be acting downwards. Okay, so on top of this 61 Newton downwards, I now have another air resistance over here, which is 34 Newtons. Okay, let me draw this down. Okay, so now I have one more air resistance, which is 34 Newtons. Going downwards. Okay, so now they do not want you to do any calculation, but they want you to describe and explain the motion of the balloon when the air resistance has this value. Okay, so now I want to describe the motion in terms of all the forces given to me. So step number 1, I need to identify the individual forces. So I have an upwards force, 95 newtons. I have a weight, 61 newton, and air resistance, also downwards, which is 34 newtons. So I'm comparing all the individual forces. So step number 1, I identify that now there is a total downwards force of 34 plus 61, which is 95 newtons, and there is also an upwards force of 95 newtons. So step number 2, I say that all the forces are balanced. The upwards force equals to downwards force. The resultant force is 0. Okay, so I do a comparison. Upwards force equals downwards force. Resultant force is 0. Okay, talk about individual force. Talk about resultant force, step number 2. And then I need to link it to the motion. Okay, so resultant force is always linked to acceleration because F equals to ma. So if the resultant force is 0, acceleration will be 0. So now the balloon will move up with 0 acceleration. If you want to elaborate more, then you can say, so the balloon will continue moving up with a constant speed because the original motion of the balloon is already moving. So it will continue to move at a constant speed. Okay, so basically these are the 3 types of questions that could possibly come out. Okay, and that's it for for the end of this part of the video.